is a very important review for exam 3 for college physics. I'm just going to focus on certain topics that you will be tested on, so make sure you understand these topics. Number 1, density. Density is mass divided by volume. And this is an example. We got to find the mass of water in a rectangular tank, which is 2 meter times 1 meter times 0.4. So those are the dimensions of the tank. So what we do is, knowing that the density of water is 1000 kilogram per meter cube, you plug it into this formula. We're looking for mass. The volume is length times width times height, which gives 0.8. So rearrange that and you get the mass of water in the tank is 800 kilograms. So density is mass divided by volume, and you could be asked to find any one of those quantities with the other two given. Next up, we have pressure. Pressure is basically defined as force by area, and its unit is Newton per meter squared or Pascal. But pressure due to a fluid, which is a liquid or a gas, is given by h rho g, where h is the height or depth of the liquid, rho is the density, and g is the acceleration due to gravity. So as an example, let's try to find the pressure at a given depth of 20 meters in fresh water. Now, fresh water has a density of 1000 kilogram per meter cube. So using the formula P is equal to h rho g, plug in the numbers and calculate the pressure to be 196,000 pascals. Number 3, when we come to harmonic oscillations, we know that a harmonic oscillator has total energy, which is made up of potential energy and kinetic energy. Now, total energy is given by the formula 1/2 times mass times omega squared times a squared. Omega is the angular frequency, a is the amplitude, and of course m is the mass. Now, since these three quantities are all constants, we know that for any harmonic oscillator, the total energy is always going to be a constant. But when we look at the other two types of energies, like kinetic energy, is given by this formula 1/2 m omega squared a squared minus x squared, where x is the displacement from the equilibrium position. And from this formula, if you substitute for x as a, then this term is going to become 0. That means the kinetic energy is 0 when x is equal to a. When it comes to potential energy, here is the formula 1/2 m omega squared x squared, which clearly shows that when x is equal to 0, you're going to get the potential energy to be 0. So remember that when one is maximum, the other is going to be a minimum. Now, next we have the equation of continuity, where when a liquid flows through a tube with different area of cross sections, where the cross section is narrow, it's going to flow faster, as given by this equation A1V1 is equal to A2V2. So here is an example. If the radius is 2 centimeters, we know the area is pi r squared for a circle, since this is circular. And then if at the other point, the narrow region, if the radius is 1 centimeter, likewise you can calculate the area. Once we have the two areas, just plug it into this equation and you will be given the velocity at one point. Let the velocity here be 1 meter per second, and we are asked to find the velocity v2. On simplification, you get v2 as 4 meter per second. Next, we have period of oscillation of a spring. You know that every spring has a spring constant. If it's a tight spring, the spring constant is going to be bigger. And the time period is given by 2 pi square root m by k, where m is the mass attached to the bottom of the spring. And in this case, we neglect the mass of the spring because we imagine that the mass of the spring is negligible compared to the mass attached. So here is this question where the spring constant is 4 Newton per meter, mass attached is 0.2 kilogram, find the time period of oscillation. Using that formula, we're going to get 1.40 seconds. Next is the period of oscillation of a simple pendulum. Now, the period in this case depends on the acceleration due to gravity, as given by the formula t is equal to 2 pi square root of length by acceleration due to gravity. So as an example, if the length is given as 1.2 meter and the acceleration due to gravity is 9.8 on the Earth, we can calculate the period of the simple pendulum. We get 2.19 seconds. Remember that I'm just doing direct applications of the formula so you understand what each term stands for. And now we have a linear expansion. Basically, a linear expansion or the change in length when you heat a metal rod is given by the product of the original length, the linear expansivity, which is a constant for each material, and the change in temperature. So the original length, the constant, and the change in temperature through which it is heated. So as an example, let's say that the original length of the rod is 25 centimeters and it is heated from 20 degrees Celsius to 80 degrees Celsius. So what is the change in length? In fact, here the question is what is the new length? And alpha is given as 25 times 10 to the negative 6 per Kelvin. So direct application into the formula, we can keep this in centimeters, there's no problem. And 80 minus 20 is the change in temperature, so we get it as 37,500 times 10 to the negative 6, which is 0.0375 centimeters. Now that is the change in length. So if we wanted to find the new length, then we would have to add 25 with 0.0375, which will give us 25.0375 centimeters is the new length. So you may have noticed that metals don't expand that much when heated. It's a really small increase. So keep that in mind when you're looking for the answers. Now moving on, we come to the ideal gas equation, where pressure times volume is equal to nRT, where N is the number of moles, R is the universal gas constant, And T must be in Kelvin in this formula. Okay, and R is 8.314, which is a constant for all gases. And again, if pressure is a constant in this equation, then we come to the conclusion that the volume increases with change in temperature, so the ratio must be equal. V1 by T1 is V2 by T2. Likewise, if the volume is kept constant, then the pressure changes with the temperature, so you have the same kind of ratio. Now, heating an object, or even when an object cools, we use the formula Q is equal to mcat, which is mc delta T. C is a constant called the specific heat capacity. M is the mass, and delta T is the change in temperature. So as an example, we have 2 kilograms of a material, and the specific heat capacity is 400, and if the change in temperature is 20 Kelvin, we get the quantity of heat required is 16,000 joules. All right, but if it's a change of phase, like the melting of ice or water changing into steam, then we do not use this formula. Instead, we use the formula mass times latent heat, where latent heat is once again a constant for that substance, and it will be given. So remember that there are 2 different formulas depending on if it's heating or cooling, or if it's a change of phase. And also, when you mix a hot object with a cold object, the hot object will lose heat and the cold object will gain heat. And the heat lost by the hot object will be exactly equal to the heat gained by the cold object. So the hot here has mass, mH, CH is the specific capacity, and TH is the temperature. Likewise, the cold one has its mass, specific capacity, and temperature. Now, if you mix them, can we calculate the final temperature? So that's what we are trying to find. To get the final temperature, look at the heat lost by the hot one, which is equal to the heat gained by the cold one. And both can be calculated using mc delta T. So mc delta T for the hot is equal to mc delta T for the cold. And then when you substitute the change in temperature, that's where you have to be careful. We know the hot one is going from 70 to a lower temperature TF. That's why we take 70 minus TF. But when we come to the cold object, we know TF is going to be bigger than 20. So we take TF minus 20. So it's always bigger, take away smaller. And then when you solve this equation carefully, we can calculate the final maximum temperature. I've distributed this and then bring the TFs, both the TFs to one side, and you get the final temperature is 22.28 degrees Celsius. And then we have conduction. Heat transfer by conduction is given by the formula Q by T is Ka Th minus Tc by D. Now I want to show you what these terms stand for with a simple example. Let's say you have a material in the form of a rectangular slab. The length is 6 meters, the width is 5, and the thickness is 10 centimeters. The K for the material is given. It's called the thermal conductivity. And the area of the face in this case is 6 times 5, right? 6 times 5 is the area, which is 30 meters squared. And D is the thickness, which is in centimeters, so I've changed it to meter. TH is 50, TC is 20. Plug it into the formula, we get the quantity of heat conducted in 1 second. So T here is time, and we get the quantity of heat conducted in 1 second as 7560 joules per second. So the problem may ask you to find the total heat conducted in any amount of time, for example, in 10 minutes. So heat conducted in 10 minutes is simply (7,560) times 600 seconds, because 10 minutes is 600 seconds. So that's how you calculate the quantity of heat conducted. And then we have radiation. Heat lost by radiation is given by the Stefan's law, which is this formula. And in this formula, you need to know that E is the emissivity, A is the surface area, okay? So if it's a sphere, the surface area is going to be 4 pi r squared. I'm going to write that. But TO is the surrounding temperature, T1 is the temperature of the hot object. Now, very important, sometimes the surrounding temperature will not be given. If the surrounding temperature is not mentioned, just take it as 0. Right? Sigma is a constant, and let's work out this problem. Taking E as 0.8, and if the radius of a sphere is given, you got to calculate the area using 4 pi r squared. Now that's important to remember. A is 4 pi r squared. I changed the centimeters into meter and found the area. Sigma is 5.67 times 10 to the negative 8. And let's assume that the temperature of the hot object is 500. So now plug all the numbers into this equation. E, that's A, sigma, T1 raised to 4. Now see that T0 is assumed to be 0 because nothing is mentioned. And you get 89 joules per second. So those are some of the important concepts. Try to focus on these concepts and then study the others a little bit. But these are the main topics on which you're going to be tested. Thank you and good luck.